when we're machining things, one of the more important aspects that need to be maintained is something called surface speed. And surface speed is, if you can imagine your tool is round, and then if you were to unroll it into a line, you have its circumference, right? So this is its circumference. And as this tool is rotating, the speed of the cutting edge has a linear value. So it's RPM times the circumference. So say at 1,000 RPM, if you've got a 2 millimeter tool versus 1,000 RPM and a 10 millimeter tool, your surface speed is going to be much higher over here because you've got a higher circumference value. So the surface speed is important because different materials like to be run at different speeds. For instance, on plastic, if we run a surface speed that's too high, the friction can be too high and cause the plastic to melt and not cut or be clean. And in zirconia, we actually want a low surface speed, relatively low. And that's because zirconia, when it's cut, it basically creates a powder. It's kind of more of an abrasive process than a cutting process. So we're making a little pile of little tiny powder grains, if that'd be a good word. Versus if you're machining plastic or metal, as the cutting edge rotates through the material, we're going to create a little sliver here. And by the way, that sliver is called a chip. Zirconia doesn't chip, and because of that, we want a lower surface speed. And the reason that that has been decreased is to help with your surface finish. So we're going down in the RPM range where the cutting edge is happier in the material for finishing. That's the biggest reason for running it at 8K. And then the second reason is the overall stability of the cut. So at a lower RPM, we're creating less vibration and we have a higher amount of stability. And all of that is being combined into let's get a better, more stable surface finish.